Hello everyone, my name is Kushal Modi and today I would be sharing you about our assignment 1's part A. Part B would be covered in a separate video. So in part A I am going to cover what is GitHub Copilot and by using it what tasks that I have done that were given for the part A. So let's go into the depth. So as you can see my screen right now, GitHub Copilot is nothing but a autocomplete smart autocomplete tech code smart autocomplete coding tool that can help you complete the code for whatever comments or coding that you are writing. For example, if you see go into this parse expense py, like you can see if somebody has written like a define a parse expense and just write down what they need, then it would help us simply write down the entire code. The copilot suggests this entire part of the expenses and everything. So to use this GitHub Copilot, all you need is a GitHub account, and if you are a student, it is free for you. You can simply I have set up my environment in VS Code, that is Virtual Studio Code, and it is very simple. You just go to the marketplace in VS Code and click on install into the GitHub Copilot. Once you do it, like you have to sign in into your GitHub account, and it will click. You have to authorize it through the Visual Studio Code, and after you are done, you are like ready to go. You ready to use it. You just have to close your VS Code once, like after installing it, and open it again. So in order to use it. Like after this, as you can see the example here that has been shown, like open Visual Studio Code, like you create a new JavaScript file and like type the following function. While you do it, like it would be a mention, like code would be by suggested by you by the GitHub Copilot, and you just do the tab button and it is done for you. So let's go ahead and try and doing this. So this is the coding part that I have done. Let's see, like I deleted the coding part, and as you can see, it is simply like suggesting me for calculate days between dates, and that's it. Like it is so simple that the entire code is done. So now, like let's say demo file dot demo 2 dot py, and let's say. Uh, Yeah, let's take this. Solving MNIST using TensorFlow Keras and a CNN. So as you can see, it started giving me suggestions for the entire coding part of the. It is sometimes it takes some time, but it is fast enough to give us the next lines like this. And so it's a really powerful and useful tool for developers. And as you can see now, load data set and everything, like you can simply just go ahead and load your data set, normalize the data, and it issues. So this way I have done two tasks that were assigned to me in my like in the assignments part A. So for the first part, I won't be going over both the I'm not going to run both the files. I'll just be simply going to run the first file because it takes this is I'm just having CPU not TPU, so it will take a lot of time. So I would be just going ahead and try to run this Keras based neural network on MNIST. The other one that is there, that is Toxic Train. I will go over both the codes, but would be running one. So in the first Keras-based neural network, this is done using GitHub Copilot only. So it suggested me multiple, like I just write down the comment, like I want to solve MNIST dataset using TensorFlow Keras and a convolution neural network. Then it started telling me like importing all the modules that were necessary according to that, then loading the data set, normalizing the data using xtrain and xtest, and dividing it by 255, reshaping it, defining the model by using like sequential model and adding multiple layers of convolution 2D layers to max pooling and flattening it and dense layers at the end. Afterwards we are simply compiling the data, model.fit for training the data, for evaluation model dot evaluate, and finally we are saving it in a h5 file, like mns.h5. So it is storing the file here. and we are predicting models. We are printing the predictions, printing the accuracy, and finally we are going through printing a graph of like validation loss to the plot loss. So let's go ahead and try to run this code. So simply what I will do is um, I'll just simply go ahead and run this file. As you can see, the it has started running on this machine. Like as we don't have a GPU setup on our local machine, so it will be using CPU. Yeah, as you can see, like I have set the machine for to run for 5 epochs only, because for 10 it will be taking much more further time. But you can go and try to do it for like, but the model converges within 5 epochs, so it gives us a really good accuracy as well, as you will see at the end. So it is running right now. While it is running, I will show you uh, like the how powerful GitHub Copilot is. Like you should definitely give it a try, because it helps you a lot into your day-to-day life. Also, it gives you multiple suggestions. The first suggestion, it is like really good because it saves a lot of time and space complexity as well. So I tried recommending doing that, and as you can see, the machine is running our model, training the model on our CPU, and as you can see on the second epoch only, the like model is converging so good. Like we are getting almost 98.5% accuracy, and we would be getting something over 99% accuracy till our epochs are run, and we'll finally get the output of the file, an image at the end of the completion of the file that is this has been run. Till then, let's wait for the file to complete. Fourth epoch is, as you guys can see, the fourth epoch is running right now. We got a loss of 0.03 3% or something like that, and the accuracy is almost 99%. No, in our third epoch only, third run of the entire while training the model. And yes, so like as you can see, for while running for the fifth epoch, it is the starting was anything around 99.3, or now we are going around. So for this, I am guessing we would be getting an accuracy nearby anywhere near between 99.25, 99.25% or something like that. Yeah, we got 99.33, which is even better. So, like the accuracy is 99, overall accuracy is 99.11%. And finally, it is the predictions that we printed. These are the values of the predictions, and we are saving the model in mnist.h5 files. So, if you ever want to load the model, we are using mnist.h5 files to previously load it. And like for printing the accuracy and everything, we are just printing model.evaluate. It would print evaluation of the model, like how much is the loss and how much is the accuracy. And it is running again for the 5 epochs, how much is the accuracy in that, our validation loss and validation accuracy. And finally we would be printing graph of validation loss to plot the use of loss and validation loss. Yeah, also for this code, I don't need to download any dataset, because the dataset is already being taken from online, from the TensorFlow's Keras dataset. So like it is already inside the system. Like for most of the times you have to take the data set and like load it so that you need to train the model. But for MNIST, it is like available in TensorFlow Keras only. So it is not a big issue. But while going through the second code of doing the neural network using PyTorch, in which we are figuring out like how much we are going over okay, we are tokenizing it using the BERT tokenizer for data of whether the how much toxicity is there in any tweets, like the Twitter data that has been taken from the users, like whether a tweet is positive, negative, or neutral. Based on that, we are finding out how much toxicity is there using the BERT tokenizer. So, like once this code is done, I will go over that. Um, Code that is all this is also be done using GitHub Copilot. Like I don't need to use a lot of my brain. Like most of the things were predefined, and like it suggests you the best things, like a little bit changes here and there, but like not major changes. So as you can see, this is the graph that has been like we can even save this figure and like zoom in to forward to the next preview or something like that. So this is the testing and train accuracy. And as you can see, like according to the coordinates, my near x and y is also changing. So this is that. And let us go over to the next PyTorch based neural network. So here, as you can see, I have taken a bird data set in which I have taken init method in which I'm taking text labels and max length. Defined different parameters which were already suggested by the GitHub Copilot. I have declared a toxic model, like length of the and then get item I am doing. Simply class of toxic model defined init method in which there is BERT model we are using that is pre-trained, dropout method and classifier forward training method, like for each epoch how many times you run it, like loss function is there, model evaluation, validity on our valid data set. Like there are three types of data: train data set, valid data set, and test data set. So validity loss and validity accuracy. And finally, I have to take this data set from like a toxic train and toxic valid from the internet, and it is very long, like having more than 10,000 values. So for 5,000 here, I am keeping this and 100 values, but it takes almost around 15 to 20 minutes, as I mentioned earlier. So I would not be going and running this entire code because it will take a lot of time. But yeah, next we will be covering the part B of the code. So that's it for this particular part. And as you can see, you can find this uh, code on my GitHub. I have saved the entire portion on my part A as my GitHub, and like a README file for like what is done in task one and what is done in task two, a simple single line that was mentioned. And I would be after like recording this file, YouTube link would be added here for part A and part B similarly in their respective README files. So thank you.